Okay, hello student. We are going to study on the using of the consistent deformation method to analyze this statically indeterminate task. This task has the internal indeterminate since it has more member in the B, C, E, F interval. And if you consider this task, you may see the A is the pin, right? So we may have this is A sub X and this is A sub Y. We can also determine this one, the D sub Y. And if you like, you may use the summation of f sub x equal to 0 for this one. And you can determine a sub x equal to 0, right? And also, if you like to take moment summation of the moment about a equal to 0, we have three unknown three equations. We can solve it. This one, the d sub y, like this. So we have the d sub y times 9d sub y. And then that is going to equal to what? 4.5 times 3. 4.5 times 3. And then plus 3 times 6 plus 3 times 6. And then you may determine this is 18. And then in this d sub y going to be 3.5 kilonewton. So this is can be 3.5 kilonewton. And this is 0 kilonewton. And you do the summation of f sub y equal to 0. So the a sub y can be determined. It's going to be this one plus this one, 7.5. 7.5 minus 3.5. This is going to be 4 kilonewton. See? You can solve for the reaction. Not only that, you may also, if you take the A here and you cut the joint of this X and this Y, and this is what? 4 kilonewton. So you can determine the force in the AE and AF. The AE is supposed to be in compression because this one up. So our F sub AE should be here, F sub AE. And this one, when it's project, is from the right to the left. So this one going to be in tension. This is going to be F sub AB. And you may also know that this is going to be what? 4 and 3. 4 and 3. Okay, again, based on this, which equation you going to use first? Which equation? I just want to solve some that we can determine, and then we will later show you the consistent deformation method. So which one is first? So this one, if you do the summation of x sub x, you cannot get the result, right? Because you have two unknowns. So you do the summation of f sub y equal to 0, and downward is positive. So you get this one is the downward times 4 divided by 5. So you have f sub AE times 4 divided by 5. And then this one is down and this one is up, equal to 4. So f sub AE will be equal to 4 times 5 divided by 4. So f sub AE is going to be 5 kilonewton. And this is in compression. Okay, and also this one you can do it easily to determine the summation of x sub x equal to 0. You get f sub a b equal to what? 5 times 3 over 5. 5 times 3 over 5. That is going to be 3 kilonewton. Okay, you can solve everything, and now you get this one plus 3. This one minus 5. And you may see what they're asking us. They didn't ask us for what I'm doing here. They asked us for the member BC, member EF, member BE. And after you know this, see, even though you know the force here, you cannot cut here and so from these three forces, because we have only two equations, summation of x equal to 0 and summation of f sub y equal to 0. Okay, and also we cannot solve for this, but we also still can solve for this one, as you may have it before. This one you may put to 3.5 kilonewton. Okay, and then you may have the x and you may have the y here, and for sure you will have the compression here, and the force is F sub dF, and this one also must be in tension because of this. Okay, this is going to be F sub CD, and again you can do the same calculation, and then you get the force in this member. And if you do that, you may get this one for minus 4.775. It's going to be close to the same. Okay, you just F sub AE times 4/5 equal to 3.5. So it's going to be 3.5 times 5/4. You get this. And the last one, you get this one for plus 2.625. 625. Okay, and then you get all the answer of that, but not those in this region. This is BC. BC is here. This is CE. CE is here. Okay. This is gonna be EF. Okay, EF is here. And this is gonna be BE. BE is here. And the last one, CF, is here. CF is here. Okay, CF. And the last one is BF. See, they didn't ask us to determine what I just did to you. And how do you check this structure is going to be statically indeterminate Truss, and it says internally. Internally is due to what I'm just explained to you. You check with what? B plus R. Okay. How many B? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. B is 10. Plus R, you have A sub X, A sub Y, D sub Y. 3. So this is going to be 13. And you got to compare with the equation you have. You have two equations per choice, and times the number of choice. So it's 2 times 1, 2, 3, 4, 5, 6 times 6. That is going to be 12. So the degree of indeterminacy, degree of indeterminacy, which is DOI, is going to be 13 minus 12. It's going to be 1. So this method, we need require one redundant force, and this redundant force must be the force in the truss member. It must be truss member force, because it is internally statically indeterminate truss. And they ask us, they give us the member CE as the redundant force. So this one, the CE is the redundant force. Okay, so okay, the redundant force is F sub CE, the first step, and the truss. the redundant force is CE, so the truss can be separate into two cases. Okay, so the truss can be lead as show. Okay, after you do that, you read all the truss as show, and then you have what? You have the redundant force as F sub CE, so it's 3. Okay, and then your truss is 4 meter, it's about 1.33. And what happened is, this is going to be the same. It's going to be B, F, E, C, and this is B, A, E, and this is going to be F, D. And your task is going to be something like this. After you're going to use the redundant force as F sub E, so the member CE, you just take it out. Your structure will change from the statically indefinite to statically determinate. However, you have this as the unknown. F sub CE apply to your structure with respect to the giving load of 4.5 kilonewton. And this one is 3 kilonewton. Okay, that's what we have for this one. And then what you may have is to set the compatibility condition. So next one, we will second compatibility condition along CE line. How to set this along the CE line? Okay, and then we use the principle of superposition superposition to separate the truss into two cases as shown. Okay, so we have one is the primary truss. So this is going to be equal to and then you're going to plus another one. One truss will subjected to the applied loading, and the another truss will subjected to the redundance, and when they combine to each other, you will get the statically indefinite truss, and then you can solve from the force displacement relationship. Okay, the first one will subjected to the applied force, and we call this as the primary truss. This is 4.5 kilonewton, and this is 3 kilonewton. And again, this may call the primary truss, which is the same as here. This is primary truss. Okay, that is going to subject to the giving load, and we have another truss here. This is the truss subjected to F sub CE. Okay, so this one we put F sub CE into the truss. This F sub CE and this is F sub CE. Okay, and now we consider what use the principle of superposition to separate the truss into two cases as shown. Okay. By considering the displacement along CE line of the trusses, we have what? Under the application force, this one will some deformation, okay, but this one may also have their own deformation. The point E C will change, okay, its length. Usually it is 4 and 3, that is 5. Okay, now it's changed to C palm and E palm. So the line used to be, this is 5 meter. It is going to change to this line. Okay, and then we can subtract the length of this blue line to the length of this red line, and then we said this is the delta along the CE. Okay, it's the change of the length along the CE line before the application of the force compared to after the 4.5 kilonewton and 3 kilonewton applied to the truss. And this one also, when it's subjected to this force, this point is supposed to be moved. Usually is the CE is going to move to C palm and E palm. Okay, and we said this is going to be F sub CE CE when the force, the latent force is 1.0. And if you time it by the total of latent force, so the total deformation or displacement at this truss gonna be F sub CE CE times the latent force. Now, what we have is 0. This is equal to 0, equal to this one, delta sub CE, and plus this one, F sub CE CE, and then it's time the latent force. Now we have the latent force equal to delta sub CE divided F sub CE CE. This is going to be the compatibility equation for this truss. And next step, we're going to determine the force displacement relationship. So third, determine the force displacement relationship along CE line, okay, which is going to be delta sub CE and F sub CE CE, and by using what? The method of virtual work. Use the method of virtual work. And by using the method of virtual work, we're going to determine the deformation along delta sub CE. So what we need to is, we're going to have 1 point unit load. The nickname of this method is unit load method, right? So we require a unit load to put into the structure to produce the external virtual work, and it's going to be in the CE direction, right? Because we are going to determine in the CE. So what we have is, we're going to put this one 1.0, and this one is 1.0, and this one will produce the internal force N. What we have is this 1.0 times this displacement 1.0 times the delta sub CE. This is going to be the external virtual work. And then we know from the previous chapter, this is going to equal to internal virtual work. Internal virtual work is this N times the change in the length of each member. So it's going to be N times this is NL divided by AE. Okay, that is the first one to determine this. And we also determine this. That means is the displacement along the CE. So the 1 point unit load also provide along that. Again, we have 1.0. And now it's time F sub CE, F sub CE, CE. This is going to be the external virtual work. And it's going to equal to internal virtual work. This produce the force N. The force N will time the deformation or the displacement of each member. Since this one compute by the F sub CE equal to 1. When the F sub CE equal to 1, the Truss here going to be the same as this one. So this one going to be the summation of N squared. And then you time L over AE. Okay, that is the two equations that we are going to use to solve this problem. And now we are going to determine the axial force in the Truss members. Okay, that is going to be this one N and also this N. Okay, and what happened is the problem gives us the N already here, the capital N. So this is going to be the internal force N, and this is going to be the internal force small n. So now we got to set up the table to compute what we should have here, right? Okay. 1, 2, 3, 4, 5, 6. Let's have 6, total 6. Yes. 1, 2, 3, 4, 5, 6. Well, I'm talking about the 6, and I will show you this is going to be the member. Okay, and then from the equation we have the member A, B, C, D, E, F, and the author. How many members we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, you get this table. We're going to have the table because we're going to do the summation. It's convenient to do this and just text the member AB, 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 BC, BC, CD, CD, and then EF. This all going to have 3, 3, 3, and 3. Okay, you have this one for the L meter, and you may have this one for 3.0, 3.0, 3.0, and 3.0. Okay, next you may set for BE. and CF, that is going to be the length is going to be 4.0 and 4.0. And the last one, the last four, AE, BF, CE, and DF. If you do like this, you're going to get the order of this is 3, this is 4, so this is 5, 5, 5, 5, and 5. Okay, and from this equation, you have what? You have the member, you have L. AE, you don't need to because AE, they set up to be a constant of 20,000. All the members have the same AE. And then you have the N, right? So you have the N, kilonewton. And you must copy all the N from here. Like this one is going to be plus 3.0. This one plus, you said this is plus, right? It's tension, in tension, 2.625. And this one also in tension, plus 2.625. And this one is in, okay? This one is minus 3.0. Okay, and then you copy all of this. This is 4, right? This is gonna be BE 4, and this is gonna be 3. This is tension. This is tension 4 plus 4.0 plus 3.0. This one is in compression, so you put this one is minus 5.0, and this one is in tension plus 0.625. Between this, along the line of CE, there is no, so this one must be 0. And the last one is here, is compression. Okay, you must be very careful on this. Put everything into your table. And then you have the small n now. Small n. We have the n here. Okay, and is here. This is the n. So 0. This is minus 0.6, 0. And this is what? Minus 0.6. And this one is in compression, right? This one is in compression, so. And you take the order, it's going to be AE, 0. BF is this one. This one is tension. Plus 1.0 plus 1.0 CE for sure. 1.0. And this is apply force of 1.0 here. And the last one is going to be 0. Okay, now from this one you have N, small n, capital N, and L. Anyone that you time it and then it has 0, so this is 0, 0, 0, 0, and this one also 0. That helps you in the calculation a lot, right? And then you do the calculation of this, of minus 4.725. And this is going to be plus 5.4. This is minus 12.8. This is minus 9.6. And this is plus 3.25. And you got the summation of this. Okay, that is the summation of this portion. And this is going to be minus 18.6. Okay, And if you do this, you're going to get delta sub CE. Delta CE. So you got what? 4, 5 delta sub CE and F sub CE. So delta sub CE gonna be equal to this one minus 18.6 divided by AE. That means it's going to be in opposite to this direction. Okay, if you take this member, this force 1 unit, can act in this member as the tension. Okay, if this is negative, so this one going to be equal to 18.6 over AE. But the member now is going to be in the opposite of this. So the force is going to be in compression. Okay, and this one going to be in contraction. It's negative. Okay, another one, you got n square. And now L. Yeah. So for the n square, 0, n square, 0, 4, 0. And this is n square times L. This n square is plus times 3 is plus 1.08. And this is 1.08. And this is plus 2.56 plus 2.56. And this is plus 5.0 plus 5.0. And then you get the summation of this again. You have this for plus 17.28. This is plus, so it's going to in elongation because it's in tension, right? So our F sub CE gonna be 17.28 and then divided by AE, and this is going to be in positive, so this one is going to be elongation. Okay, now after this we may go by putting this force displacement relationship, and then you can find the redundant force. So 1, 2, let's see, 4, 5, the redundant force F sub CE. Okay, and then everybody can do it. F sub CE gonna be, don't forget about this one. Oh sorry, this is wrong. This is supposed to have negative here. So we have negative here divided by, this is negative 18.6 divided by AE. And then this one gonna be 17.28 also divided by AE. And you may have this one cut, and this one cut. You may get this one of 1.076. This is 1.076 kilonewton, and it's going to be in this direction. Okay, so now your task gonna be I use a bigger scale, 1.5 centimeter for 3 meter. Okay, your task is going to be like this. And follow what we have before. We have the force in this member of 1.076. This is 1.076 kilonewton, 1.076 kilonewton, and this is subjected to the force of 4.5 kilonewton, and this is 3 kilonewton. And previously you have this reaction as before of what? Of 4 kilonewton, and this is going to be 3.5 kilonewton. And you also has this one for plus 3, minus 5, minus 4.77775, and plus 2.625. Okay, now that is you guys gonna do determine the force in this member, in this member, in this member, okay, and in this member, and then you can answer into this, right? As it's going to be A, B, C, D, E, F. You do by using the same method of section or method of choice. Mostly you're supposed to use method of choice. Okay, after you're doing that, you're going to get this one for 1.979 kilonewton is in tension, and 646 must be 646 kilonewton, and it's going to be in compression. And then this one going to be 3.139 kilonewton, also in tension. This one we also have it for 1.076 kilonewton in tension. And this one is 1.701 kilonewton in tension. And the last one is 2.139 kilonewton in tension. Okay, after you do this, you're going to get all of the required forces in the member, and you may see we have the maximum force of 5 in compression here. Okay, this is less than 5. Okay, that is for the clips of the statically indefinite truss by using the consistent deformation method. This one's special because it's internally statically indeterminate. So we use the truss member force as the redundant. So we use the CE. Let's we use this. When we use the CE, the structure will change from the indeterminate to the determinate. However, the force F sub CE is going to be the redundance. And then you can separate this truss into two cases based on the principle of superposition. One subjected to the applied force, another one subjected to the redundant. And if you consider the deformation of this structure, especially along the CE line, you can write the compatibility of 0 equal to delta sub CE plus F sub CE and times the redundant force. So the equation of the redundant force is going to be this one. Don't forget the negative sign over here also. Got this one for the negative side. And then the problem change into the what we have learned before, determine the force displacement relationship by using the method of virtual work or any method that you like. And finally, you get the F sub CE of this. Okay, when you get this, you put into this equation. Sorry, you put into for free body diagram. And then you may cut this one between this force and this force. You may cut this one between this force and this force. And later you can determine this force. Okay, this is the end of the clips. Okay, I hope you guys enjoyed it and try to do it by yourself. Okay.